Hello, this is Yellowman Physics, and I just want to take a little bit of time to talk about kinetic energy. Now, as Yellowman shot past us then, he had kinetic energy. And kinetic energy is an energy we associate with things that move. So any object that's moving will possess this idea of kinetic energy. It is doing something, it is moving, it has this energy. Now, there's two things that affect how much energy or kinetic energy a moving object has. One thing is how fast it's going. Well, that's really slow, isn't it? Try that again. So he didn't have a great deal of kinetic energy then because he wasn't moving very fast. So the two things, how fast he's going, and the other thing that affects how much kinetic energy an object has is how heavy that object is. So if I make Yellowman heavier by adding some masses to him, right, we'll try again. If I make Yellowman heavier by adding some masses to him, then when he's moving, well, he's obviously not feeling it today, is he? So when he's moving, pretend my hand's not there, people, he will have more kinetic energy. Right? So things that are moving faster or things that are heavier have more kinetic energy. I think he needs a break. So how fast they're moving and how heavy they are, or the mass. So that's a bit more of a sciencey word, isn't it? Mass. Let's get rid of that and let's put speed. Okay, so like all things in physics, or many things in physics I guess I should say, there is an equation for kinetic energy. And the equation for kinetic energy, I'll write it as letters first. So that kinetic energy is equal to 1/2 times the mass. Now actually we use velocity and we square it here. So I'll write this out as words and then I'll talk about this more. Kinetic energy is equal to 1/2 times mass times velocity squared. Now, this is the thing that gets bigger when his mass increases, which makes the answer bigger. If I increase the velocity, then this number gets bigger, and it gets even bigger because it's squared, which again increases the amount of kinetic energy that an object has. Now don't be put off by the term velocity here. Some places will refer to it as speed. I normally will talk about it as speed. Strictly speaking, we do call it velocity. The difference between speed and velocity is just that velocity has a direction, it's a vector, whereas speed is a scalar, it doesn't have a direction. So an example of a speed might be 3 meters per second, and an example of velocity might be 3 meters per second north. Now, you can switch off for the next couple of seconds if you don't care much about maths. In terms of physics, this direction goes away when we square it. So squaring it will get rid of this direction. So effectively what we do here is we use speed anyway, right? So we don't worry about it being a vector when we're working out kinetic energy. The squaring gets rid of that. Okay, so I think what we need to do is look at some examples so that you can get your head around how this works. So this problem, Yellowman has a mass of 50 kilograms and is moving at a speed of 8 meters per second. Calculate his kinetic energy. So first thing we do is go, right, we know what the kinetic energy equation is, and it is KE is equal to 1/2 times mass times velocity squared. I look at what I've got. I've got 50 kilograms, a mass of. I've got a speed of 8 meters per second. It's asking me to work out the kinetic energy. That's the kinetic energy. That's the mass. And this thing here is speed in a direction. Don't care about the direction because I'm working out the energy. So that is the speed. I've got everything I need. So substitute my numbers in. 1/2 times 50 for the mass times 8 for the speed. Don't forget the squared. Put the squared on the top. Grab my calculator and have a go. So for the half I'm going to type in 0.5. For the mass is 50 and move it along slightly. I've got an 8 and the square button is that x to the 2 up there, and that tells me that my answer is 1600. Now energy is energy is energy, and 1600 for kinetic energy is always going to be measured in joules. Energy is measured in joules, whether it's kinetic energy, gravitational potential energy, chemical energy, or whatever you want to think about. It's always going to be joules, and because joules was named after someone, it's a capital. Just like you write your own name, you write a capital for your first letter. This is a capital for their first letter, so it's 1600 joules. So something I should have said beforehand when we looked at the equation, but sometimes it can just get a bit long, is when we have this kinetic energy equation, and this is a useful way to make your notes sometimes, and we're talking about all of these different things. Kinetic energy, joules, mass, kilograms, velocity or speed with a direction, meters per second squared. So when we're doing a kinetic energy problem, we want the mass to be in kilograms, we want our speed to be in meters per second, and our answer will come out in joules if we keep to this convention. And I think we need to have a look at an example of what I'm talking about. Okay, so let's ditch Yellow Man. Let's clean this board and let's go with a slightly different example. A fish of mass 200 grams is swimming at 200 meters per second. Find its KE. So we know the kinetic energy equation. I'm just going to write it out as letters now, trying to save a bit of time. 1/2 times mass times velocity squared. If I wanted to save even more time, I could write this all together, following the rules of algebra, like this. Now, we substitute in the numbers to find the answer. Kinetic energy is equal to 1/2 times mass. I look at the mass is 200 grams, but I'm a physicist and I'm not as weak as other people. I always work in kilograms, alright? So 200 grams is not kilograms. I need to convert this into kilograms. There are 1,000 grams in 1 kilogram. To convert this, I divide it by 1,000. Alright? Dividing it by 1,000 gives me an answer of 0.2. So 200 converted into kilograms is 0.2. Happy with that. And my speed was 200 meters per second. And don't forget the squared. Now, quickly tap that into my calculator, have a quick go. Gives me 4,000. I'm a physicist, I must write a unit with my answer, otherwise I'll cry inside a little bit. 4,000 joules. Now, If I had forgotten about this 200 grams, my answer would have been this. Yeah, it's quite big. Oh, and it's so big it's gone off the page. Much bigger number. Now, normally, particularly with AQA, which is the exam board that I'm focusing on, if this question, say, was out of 3 marks overall, this answer would gain you all 3 marks. This answer, you would lose a mark. Okay? So forgetting to convert will lose you a mark, but 2 out of 3 isn't bad. So don't stress it if you forget to convert these things. The exam board know that people forget. They know that students will, under the pressure of an exam, forget to do this, and they will still include in their mark scheme allow a mark for this answer, but you can't achieve the full marks for the question. Now, for a kinetic energy problem, this is as good as it gets, okay? You've rearranged the equation, you've shoved in a square root to cancel out a square, and you've got an answer for the speed. This is the top end of an exam question, working out the speed of the object, because it involves this rearrangement and square rooting, 2 mathematical steps. Right, quick problem for you to try. I want you to have a go. Pause the video, I'll give you the answer. Kind when you unpause it, I guess. Okay, so we write out the kinetic energy equation. We look at the values that we've got. We've got a mass, we've got a speed, and it's asked us to find the kinetic energy. So we're finding kinetic energy. Kinetic energy is equal to half times 18 times 3 squared. Grab my calculator. 0.5 for the half times 18 times 3 squared. Gives me an answer of 81 joules. Well done if you got that. You guessed it. Slightly harder question. Have a go. This cat is chasing the mouse. What's its T? I've given you its kinetic energy. I've given you its mass. I want to know how fast the cat is going, how fast it's running. Have a go. Pause the video. We'll go through the answer in a second. Hoped you paused it. Hoped you've had a go. So, kinetic energy is equal to half mv squared, as always. In this case, I've got a mass, I've got a kinetic energy, and it's asking me how fast. So I've been given this number. So instead, I write it in, 800 joules, equal to a half, mass is 1, and the thing I don't know is the speed. Now anything times 1 is just itself, so I can forget about this middle one here, doesn't matter, but I need to get this 2 over on this side because I want to get v squared on its own. So 800 times 2, well, let's leave the 1 in there, times v squared. 800 times 2, do it with my calculator, but I think I'll have a go. 1600 equals 1 times v squared. V squared still isn't on its own. I do the opposite operation of whatever number is here. It's times in v squared, so I divide. In this case it becomes 1600 divided by 1, which is still just 1600. Now at this point I've got 1600 equal to v squared. V squared isn't quite on its own, and I still need to do the opposite operation of squared, which is square root. Gets me to here. I get my calculator, I type square root 1600, try again, square root 1600 gives me 40. So V is equal to 40. I'm a physicist, I must always write a unit with my answer. The cat is travelling at 40 meters per second. Depending on how far away they are, there's quite a good chance that the cat's going to catch the mouse. If you're after the top marks in the kinetic energy equation, or the exam board are looking to really stretch you, they will go with a question where they give you the kinetic energy, but they ask you to find out the speed of the object. So what this means is, we know our equation is this, and the exam board, in their question, give me this number, they give me this number, and they say, work the speed out. So, this is the one that requires a little bit more maths and the use of the square root button on your calculator. Okay, so let's go with an example. The cat has 1600 joules of kinetic energy. And a mass of 3 kilograms. No bear trap, I'm just going to put it as a kilogram. Find the speed of the cat. So, dig out our equation. Kinetic energy is equal to half mv squared. Put in our numbers. Our kinetic energy is 1600 joules. Half is a half. Next one is a mass. Do I know the mass? I know the mass. Good. Velocity squared is the thing that I do not know and I need to find out. Now, a couple of different ways of approaching this. Outcome is generally the same, at least you hope so anyway. I've got this side is all being divided by 2. So to balance this out, I want to get v on its own so that I can do something with it. I'm going to start by unpicking this side. It's divide by 2 on this side, so I'm going to times by 2. So 1600 times by 2 is equal to 3 times v squared. Taking this 2, I've moved it up. On this side, v still isn't on its own, it's being times by 3. Opposite of times by 3 is divide by 3. At this point, v is almost on its own. Got 1600 times 2 divided by 3 on this side equals v squared. Depending on your maths, to be honest, I think I'm going to work out this side now because I just want a number. I'm getting bored of writing all of this out. So 1600 times 2, press return because I'm scared of my calculator. Now divide that by 3, going to give me some kind of nasty number. 1066.6. I'm not going to write the recurring because we don't like that in physics. I'm just going to leave it as that for a second. Equals v squared. V still isn't on its own. The opposite of squaring something is square root. So I square root all of this side. I square root my answer, cancels out my squared. Now, luckily, I've left the number on my calculator. I'm just going to press square root, answer, return. Gives me a speed of 32. It's 0.65 here. I'm going to round this up to 32.7. And I'm a physicist who's running out of space. Meters per second. Meters per second as it disappears off the screen. Try that one again. Perhaps. Okay, to summarise, we've looked at kinetic energy. Kinetic energy is the energy of anything that's moving. Moving. So any object. It's movement energy. Units of kinetic energy are joules, like all energy types. Mass is always measured in kilograms. Velocity is always measured in meters per second. Affected by mass and speed, happy with that. The hard questions that they're going to give you, they're going to want you to find out the speed. You rearrange the equation and then you square root to get rid of the v squared. Thanks for watching.